Welcome to the next in the series of lectures on gas laws. You are going to need a pencil or a pen and paper. You are definitely going to need your calculator. As we go through this video, pause as necessary to write concept or application questions or clarifying questions that you may have. Hopefully we will solve those, or we will answer those questions as we go through this lecture. If we do not, I strongly recommend that you address those questions with your instructor before we go on to the next section of this lecture. With the combined gas law, make sure that you have your standard temperature and pressure information, which by now you should have memorized. But the standard temperature is the temperature at which water freezes, and we use degrees Celsius. So at 0 degrees Celsius, water freezes, but in order to do our problems so that we don't have an undefined or a zero answer, we convert our Celsius into Kelvin, so it becomes 273 K. Please note that degrees Celsius has a degree, Kelvin does not. Remember, in order to go from degrees Celsius to Kelvin, we add 273. And to go from Kelvin back to degrees Celsius, we take away 273. And that will get you back to degree Celsius. Okay? Also, make sure again that you have your standard pressures. And remember that our standard pressure at standard temperature and pressure is 1 atmosphere, or 101.3 kilopascals, is 760 torr, or 760 millimeters of mercury, or 14.7 psi. Make sure that you know these by heart. If you don't have them beside you, write these down quickly. Pause the video, write them down, and then continue when you're ready. So the combined gas law takes all the gas laws of Charles, Boyle, and Gay-Lussac and puts them all together. And it allows us to solve any of the three laws that we've just gone through. The reason we've taught them to you separately is so that you could see the relationship between the variables. You could see that with Boyle's law, pressure and volume are inversely proportional to each other. That means if you increase the pressure by a certain amount, you're decreasing the volume by a certain amount. With Charles' law, we wanted you to see that volume and temperature are directly proportional to each other. If you increase the volume by a certain amount, you increase your temperature by a certain amount. For Gay-Lussac, we wanted you to see that pressure and temperature are directly proportional to each other. If you increase your pressure by a certain amount, you increase your temperature by a certain amount. Now we get to see all of them related to each other in what we call the combined gas law. This is the combined gas law. Make sure that you know the formula for the combined gas law, and you know that it is the combined gas law. Here again, you have pressure in different conditions. In one condition, you have a pressure, volume, and a temperature. In another condition, you may have made a change in the pressure. You may have made a change in the volume. You may have made a change in the temperature. We will give you, or you will be able to get at least 5 of these variables, but then you're going to have to solve for the 6th variable. Okay, make sure you write this down. Put a star beside it. Make sure you know that you need to know this by heart. And when you're ready, continue or pause the video or rewind the video if you need to get a little bit more clarification on a question. So let's get ourselves started. Okay, as usual, we are going to work in Kelvin. We are going to report in degrees Celsius. So, given 500 milliliters of gas collected at 27 degrees Celsius and 140 kilopascals, we have to find the volume at a -3 degrees Celsius and 90 kilopascals. Well, we're going to do this kind of slow, so just bear with me. Okay? We can see from our given that we have a volume in condition 1, we have a temperature of condition 1, and we have a pressure of condition 1. In condition 2, we don't know the volume, so we know we need to find that. But we do have a temperature in condition 2, and we have a pressure in condition 2. So what we're going to need to do is first we have to make sure our temperatures are workable. We can't work any of this in degrees Celsius. So for temperature 1, remember I'm limited in space, I have 27, and I'm going to have to add 273. So get your calculator and take 27 plus 273, which is going to be equal to 300. So my temperature 1 is 300 K. And then my temperature 2 is a -3 plus 273. Even though that's a small number, you still got to add that to 273. And that's going to give me 270 K. So T2 then is 270 K. So my formula for combined gas law, and I'm going to put that in a different color just so we can see the difference in them, okay, is P1 V1 over T1 is equal to P2 V2 over T2. Again, it's a plug and chug, which is what I'm going to do. So I'm going to take my P1, which is 140, times V1, which is 500. And that's going to be divided by T1, which is 300. That is going to be equal to P2, which is 90, times V2, which I don't know, divided by T2, which is 270. Okay, now I have to cross multiply. Cross multiply and divide. This is going to make a linear equation, which is going to be, open parentheses, 140 times 500 times 270 equal to 300 times 90 times V2. And I want to solve for V2. So in order to get that 300 times 90 away from V2, I have to divide 300 times 90. Divide both sides by 300 times 90. And see how I'm putting them in parentheses? Because that's going to help me when I'm writing them in my calculator. This is going to cancel on this side. So open parentheses, 140 times 500 times 270, close parentheses, divided by, again, open parentheses, 300 times 90, close parentheses, push the equal sign, and your answer should be 700. And since I'm talking about my volume, I gave you milliliters, you give me milliliters back. Okay, if you need to, go back and rewind this video for this problem. If you're comfortable and you got 700 milliliters, go ahead and press play and we will continue on. Convert to standard conditions, 2,280 milliliters of gas at 30 degrees Celsius and 800 kilopascals. Okay, so we know that our V1 is 2280 milliliters, our T1 is 30 degrees Celsius, and our P1 is 800 kilopascals, But I need to convert these to standard conditions. Well, what are standard conditions? Standard conditions are STP, standard temperature and pressure. Well, what's my standard temperature at standard temperature and pressure? Well, temperature at standard temperature and pressure is equal to 0 degrees Celsius, right? And pressure at standard temperature and pressure is based on my unit for pressure, which here is kilopascals. My standard pressure is 101.3 kilopascals. Okay, so now I have everything except for V2 because it doesn't tell me. So V2 is what I'm looking for. The first thing I have to do is I have to fix my temperatures. So temperature T1 is 30 degrees Celsius. If I add 273, that is going to give me, 303 Kelvin. And temperature 2 is at 0 degrees Celsius, and I add 273, that is going to give me 273 K. So now I know what my temperatures are. And again, work with me because I'm working with limited conditions. So my T1 then, I'm going to put 303 K. And my T2, I'll change that to 273 K. Gives me the parameters that I need. So now I can get rid of this and get myself some working room. Okay. So I need to set this up. Again, I know that my formula for this is P1 V1 over T1 is equal to P2 V2 over T2. So it's a plug and chug. So let me plug my information in. P1 is 800. V1 is 2280. T1 is 303. That's going to be equal to P2, which is 101.3, V2, which I don't know, over T2, which is 273. All right, cross multiplication is going to result in a linear equation of 800 times 2280 times 273 is equal to 101.3 times 303 times V2. And I want V2 by itself, so I'm going to divide both sides by 101.3 times 303. That cancels out over here. Open your, clear your calculator, open parentheses, 800 times 2280 times 273, close parentheses, divided by, open parentheses, 101.3 times 303, close parentheses, press your equal sign, and your answer should be 16233. Since I'm looking for volume and I've given you volume in milliliters, then you're going to give me milliliters back. Okay, how'd you do? Hope you did well. If you still have questions, make sure you write those down. Hopefully we'll get through those. All right, this is your turn. You have to convert to standard conditions 5 liters of gas at 100 degrees Celsius and 201 kilopascals. Pause the video, do the question in its entirety, and then come back and check yourself. Okay, so here we're looking at V1, T1, P1. And again, I want standard conditions, which is going to be T2, excuse me, not 1, but 2. Here we go. Equal to 0 degrees Celsius. P2, I'm looking at kilopascals, so that's going to be equal to 101.3 kilopascals. And V2 is unknown, so I'm going to be solving for V2. I'm going to fix my temperatures. So T1 is equal to 100 plus 273, which is going to give me 373 K. And of course T2 is 0 degrees Celsius plus 273 is going to be equal to 273 K. All right. So I now know that my temperature T1 needs to be 373. Oops, let me write that a little bit better. There we go. 373 K. That's not a lot better, but it's better than it was. And I know that my temperature 2 is going to be 273 K. Okay, put those in place, and that means I don't need this, and I can make me some working space. Okay. Okay, so I cleaned that up a little bit so I can work. So I have to do plug and chug. I know what my formula is in this case. So P1 is 201 times V1, which is 5, all over T1, which is 373, is equal to P2, which is 101.3, times V2, which I don't know, all over T2, which is 273K. I am going to cross multiply this, as usual, to make it linear. And that is going to give me 201 times 5 times 273 equals 101.3 times 373 times V2, which I don't know. And I'm going to divide both sides by 101.3 times 373 to get rid of it on this side, and 101.3 times 373. Okay, so clear your calculator. Open parentheses, 201 times 5 times 273, close parentheses, divided by, open parentheses, 101.3 times 373, close parentheses, press the equal sign, and you should get 7.3 liters. Now, why is that liters? Because I gave you liters for my volume. So you need to make sure you give me liters back. Okay, once again, if you need to, feel free to rewind the lecture and go through it until you make sure that you understand how to do the combined gas laws. If those questions have not been answered, please make sure that you address them with your instructor as soon as possible before we get to the next section. Have a good day.